Welcome to my channel AI Basics with AK. Here we are with another new episode on descriptive statistics. So far we have seen what is statistics and types of data. Here, this is the first episode where we are stepping into the basics of really what is statistics, which is mean, median, mode, range, variance, and standard deviation. So, what is actually a descriptive statistics? Say, for example, let's take the same example that there is a kirana store and it sells milk every day, and we want to summarize and describe some information about that kirana store. What we can say, okay, last week it has sold a total of say 26 milk packets. So here we are trying to describe what has happened, or else we can also describe that on an average, okay, on an average, on each and every day, there is approximately 4 milk packets got sold. So here we are trying to summarize and describe the main features of what has. When we are describing the main features of any data set, we call it as mainly the central tendency. What is central tendency means? I'll come up with it in next few slides down the line. Let's just absorb this nomenclature at this point of time. So in this central tendency, we have something called as mean, median, mode, range, and standard deviation. What is some mean? Mean is nothing but an average, which we have described in the previous slide. What is median? Median, okay, in a layman language, it is also like a mean, but when you have a data set, mean is nothing but it's like averaging all these numbers, but median is like a middlemost value. Mode, as it mentioned here, it is most frequently occurring value. Range is nothing but a difference between max and minimum. Say for example, on an here say for example, the milk packet sold on Monday 3, 4, 5, and then again 3, 4, 5. The range is that on an average it's sold between 3 and 5. That gives you the range of how it's being sold on an each and every day. Now to summarize this, say for example, this I'm saying the mean on an average, so the mean of the milk packet is 4 and the range is 3 to 5. So it actually summarizes and describes the large information of 7 days. Say for example, here it is 6 days, in just couple of few words, which somebody can comprehend it much more clearly rather than these raw numbers. That's a most important feature of statistics, where you are trying to describe a huge data set into some meaningful information using these basics measures, which are mean, median, mode, range, and standard deviation. So here I'm trying to describe the same thing in a visual format such that people who are new to this piece can understand it. Here I have plotted, okay, all these raw numbers, like these are my exam scores. Now what we have seen, mean is nothing but like an average. You have to add all these numbers and divide it by the number of exam scores. That is actually the mean. So what is mean? You have to add all the numbers, count how many numbers are there, and assume that when you add, you got some assume that the variable name is total, and you have to divide this total divided by how many numbers are there. That will be your mean. So this red value is something that is called as your mean here. Median is like a middlemost value. You don't care about adding or dividing it. You just put the numbers in order and find the middle one. That's as simple as that. It's like, okay, what is my middlemost value kind of a thing? Then you can call something as a median. Most often when the data set is large and very balanced, mean and median would almost be the same. So that's why we have seen that these are actually almost near. What is mod? Mod is most repeating value. Okay, 100 exam score, just scored by 2, not by many people. But still, as per the rule of statistics, this becomes the mode. Look at all the numbers, find the numbers that shows most repeated. Okay, and that will that becomes your mode. Simple, isn't it? Now let's jump into min and max, which is called, you find the minimum, which is 55, and you find the maximum value, which is 100. So you call that as range as 100 minus 56, which is, say here, 44. It's as simple as that. How do you find it? You look at all the numbers, find the smallest number, and you find the biggest number, and you subtract the smallest from the biggest, you will get your range. It's as simple as that. Now, what is variance? Variance I have not described so far. Let me go back to my earlier slides. What is a variance or a standard deviation? It means how data spreads around your mean. Just absorb all these things. Okay. Now let me come back here. Now this is our mean, which we have seen it in our previous slides, which is our averaging all your exam scores. Now a value that is closer to the mean, you can see by these red bars here, it has lesser variance. The values which are farther for the mean have larger variance. This is called, concept is called variance. What is it tell is that the closer the values which are nearer to the mean, it means the data set is more balanced and tight. If the data has huge range, okay, if the range, say for example, if the range is between 75 to 85, then we can say that if the data set is only this part, then your variance is very less in the data. If the data set, say it is ranging from say 40 to say 120, hypothetically, then your variance is spread across this whole range. It means because you will have higher variance even at this location, and you might be having a higher variance at 120. So when you see all these things, the variance on this data set is so huge. So that tells that, okay, how your data spread is spread from your mean. How does this help? Let me explain it to you. Once I tell you how we calculate it. How we calculate it, you calculate the mean. You take each data point and do this subtraction. Take the data point and subtract from your mean. Let us call that as a deviation. And you square each deviation and add them up and take an average. You get a variance. This step is called variance. Once you take the square root of variance, you get standard deviation. It's very simple. You go back here, there is the mean. Okay, what is this? If we have only 75 as a value, you take 75 minus mean, you get your deviation, and then you square this number and then add all the variances and take the average. That is nothing but your variance. And then once you square root that variance, you will get your standard deviation. Now, let me go back to my original slide, which is called central tendency. What we are trying to do when we have a huge data set of say 30 days, it is not possible somebody to understand what has happened over 30 days unless we summarize. On an average, if we can say there are 4 milk packets got sold, and the middlemost on the middlemost number when we order them, it's just 3, and most frequently it is, say for example, it is again 4, and the range is between 3 and 5, and the variance is very less. Say for example, the variance or the standard deviation is much smaller, which is say 1, then we can say that we can predict what is going to happen in the next day. What does it tell? We are trying to tell how the centrally our data lies. Okay, the centrally the data lies between 3 and 5, which is very tight, and my variance and standard deviation is also very less, and on an average we are saying that mean is 4. When we have these smaller numbers, it is very easy for somebody to comprehend what might happen tomorrow based on what has happened in the last 30 days rather than going through all raw numbers. Okay, now you understand all these things. You can just go through these slides once more again, and mean, median, mode always lies center of the data, so that's why it is called central tendency. And the range, variance and standard deviation describe the spread. Together these are called how the data is behaving from center, and that does the data lies on the center. When we go into the next episodes, we will learn about some distributions of the data, which will give us more further nuances how we can describe the data. Here we have just learned some of the tools. In the next episode, we will understand how we will use these tools to further summarize in a better format. I hope you have enjoyed this episode, and for entire data science or artificial intelligence, the statistics, probability, and linear algebra is more fundamental as Python programming. So that's why I have dedicated a separate season for statistics. That's it, and we will see in the next episode. Thanks a lot.